Good morning to one and all. I am Amrit Pasing and I am here amongst you all to discuss on the deficiency of most well-known and accepted Newton's second law of motion. That means F is equal to ma. So before starting this, we will discuss what Newton's second law of motion states, and then I will deliver its limitation and give a positive alternate equation that replaces Newton's second law of motion. Here I begin. It's been a difficult task for researchers to find correct formula of force.
So far as we know, Aristotle was the first person that gave the formula of force. So his formula of force is equal to resistance into speed. Subsequently, John Buridan formulated it as impetus is equal to weight into velocity. Henceforth, Sir Isaac Newton introduced it as force is equal to change in velocity in his book Principia. And finally, Euler directly gave various equations of force F is equal to ma by 2 or F is equal to ma by n in 1736, F is equal to 2ma in 1750, F is equal to ma by 2g in 1765, and eventually introduced it as F is equal to ma in 1775.
As we can see, time to time amendments are being made since the formula of force has come into existence. So according to updated physics, F is equal to ma was discovered by Leonhard Euler. I will refer this formula as Newton's second law of motion, which it is popularly known as.
Let us assume we have an airplane at point 0, defined by its location x0 and time t0. The airplane has mass m0 and it travels at velocity v0. The airplane is subjected to an external force and it moves to point 1, which is described by new location x1 and time t1. The mass and velocity of the airplane change during the flight to m1 and v1. Let us just take the difference between conditions at point 0 and conditions at point 1. So we get that equation F is equal to m1 v1 minus m0 v0 divided by t1 minus t0. Newton's second law of motion talks about change in momentum. So at this point we can't separate out how much the mass changed or how much the velocity changed. We only know how much the product changed. So let's see what Newton's second law of motion states. Let us assume that we have an airplane at point 0, defined by its location x0 and time t0. The airplane has mass m0 and velocity v0. The airplane is subjected to an external force and it moves to point 1, which is described by a new location x1 and time t1. The mass and velocity of the airplane change during the flight to m1 and v1. Let us just take the difference between conditions at point 0 and conditions at point 1. So we get that equation F is equal to m1 v1 minus m0 v0 divided by t1 minus t0. Newton's second law of motion talks about change in momentum. So at this point we can't separate out how much the mass changed and how much the velocity changed. We only know how much the product changed. Let us assume that the mass stays a constant value equals to m. This assumption is pretty good for an airplane. The only change in mass would be for the fuel burn between point 0 and point 1.
The weight of the fuel is probably small relative to the weight of the rest of the airplane, especially if we only look at small changes in time. If we were discussing the flight of a baseball, then certainly the mass remains a constant. But if we were discussing the flight of a bottle rocket, then the mass doesn't remain constant.
For a
And we
constant mass m, Newton's second law looks like F is equal to m v1 minus v0 divided by t1 minus t0. The change in velocity divided by change in time is the definition of the acceleration a. The second law then reduces to the more familiar product of a mass and an acceleration. So we get formula force is equal to mass into acceleration. So let's have a numerical to check how Newton's second law of motion works. Suppose we apply 100 Newton force on an object and it accelerates at the rate of 2 meter per second square. Calculate force. We have a formula F is equal to ma. We just need to put the given value in that formula. So force is 100 Newton. Acceleration is 2 meter per second square. So by putting these two values we can get easily mass, right? Mass is equal to 50 kilogram, right? It's so easy. Let's shift to higher level. Suppose we apply same force, say 10 Newton to stationary weights, that means 9.8 Newton, 98 Newton and 980 Newton for 10 seconds. If weight accelerate uniformly, then calculate final velocity of each weight, right? We have a formula F is equal to ma, but we have to calculate final velocity. So expand acceleration and then move time to the left hand side and then open bracket and move mu to the left hand side and finally divide both sides by mass, right? We get that equation. This is the perfect equation in order to calculate final velocity. So what was the numerical? Suppose we apply same force, say 10 Newton to stationary weights, that means 9.8 Newton, 98 Newton and 980 Newton for 10 seconds. If weights accelerate uniformly, then calculate final velocity of each weight. We have an equation that can calculate final velocity. So we just need to put the given value in that formula, right? So in case 1, when weight is equal to 9.8 Newton, right? 9.8 Newton case 1, mass become 1 kilogram, as formula of mass is weight divided by gravity. Weight is 9.8 Newton, gravity is 9.8, so we get mass is equal to 1 kilogram. So put the given value in that formula. Force is 10 Newton, time is 10 seconds, mass is 1 kilogram and initial velocity is 0 as object is stationary, right? So we get final velocity equals to 100 meter per second. In second case, when weight is equal to 98 Newton, mass become 10 kilogram, right? Formula of mass is weight divided by gravity, that means 98 divided by 9.8, we get mass is equal to 10 kilogram. So put the given value in that formula. Force is 10 Newton, time is 10 seconds, mass is 10 kilogram, initial velocity is 0, right? So we get final velocity equals to 10 meter per second. In last and final case, when weight is equal to 980 Newton, mass become 100 kilogram. 980 divided by 9.8, we get mass is equal to 100 kilogram. Put the given value in that formula. Force is 10 Newton, time is 10 seconds, mass is 100 kilogram, initial velocity is 0. So we get final velocity equals to 1 meter per second. To conclude, we can affirm that final velocity decreases as a result of increase in weight when exactly same force is applied for same time.
It's been ages since we are using this law in every nook and corner of physics. It is a time to consider some analysis of the formula. I will request kind attention of yours to something which I have analyzed. Now, as per principle of physics, F is equal to ma, it should be established in each and every condition whatsoever. It should be universal and shouldn't prove to be deficient in any situation. I would like to consider above principle of Sir Isaac Newton into following numerical.
If we apply same force say 10 Newton on a stationary object of mass 10 kilogram but weight varies with respect to gravity, that means weight 980 Newton, 98 Newton and 9.8 Newton. If object accelerates uniformly in all three conditions, then calculate final velocity after 10 seconds in each case. We have a formula, we just need to put the given value in that formula. So in case 1, when mass is 10 kilogram but gravity increases 10 times, weight becomes 980 Newton, right? Formula of weight is mass into gravity. Mass is 10 kilogram, gravity is 9.8, it becomes 98. But in that case, gravity increases 10 times, so multiply 98 by 10, it becomes 980 Newton. Now put the given value in that formula, right? Force is 10 Newton, time is 10 seconds, and mass is 10 kilogram. Initial velocity is 0 as object is stationary. So we get final velocity equals to 10 meter per second. In case 2, when mass is 10 kilogram but gravity equals to 9.8 meter per second square, weight becomes 98 Newton, right? Mass into gravity, 10 into 9.8, weight becomes 98 Newton. So put the given value in that formula. Force is 10 Newton, time is 10 seconds, mass is 10 kilogram, initial velocity is 0, right? So we get final velocity equals to 10 meter per second. In last and final case, when mass is 10 kilogram but gravity decreases 10 times, weight becomes 9.8 Newton, right? Formula of weight is gravity mass into gravity. Mass is 10, gravity is 9.8, it becomes 98. But in that case, gravity decreases 10 times, so divide 98 by 10, it becomes 9.8 Newton. So put the given value in that formula. Force is 10 Newton, time is 10 seconds, mass is 10 kilogram, and initial velocity is 0 as object is stationary. So we get final velocity equals to 10 meter per second. To conclude, we can affirm that Newton's second law of motion fails to calculate final velocity in that scenario when weight increases due to gravity instead of mass, right? As we have already confirmed that final velocity increases, right, as a result of decrease in weight, or you may say final velocity decreases as a result of increase in weight, which doesn't happen in that scenario.
Scientists had earlier tied themselves into the established conventions of science and couldn't never free themselves out. According to my research, there were reasons for this. It was never easy for anyone to get out of established cause and effect rule and universal established rule of science, as correct formula of force was about to bring new rules in science. No one dared to undertake a revolutionizing research on the issue to bring crystal clarity into the things. Today, let's try to make some inquiry into the issue. Have you ever read even a single numerical in which you are required to calculate force when gravity is different from 9.8? No? Actually, that is the big reason why we have never experienced that error, as we use gravity everywhere 9.8 in each case.
As is evident by the numerical, we have missed the role of gravity in that established convention. I would like to restate the above formula as force is equal to weight into acceleration. Let me again consider same numerical to check whether it works or not. If we apply same force, say 10 Newton on a stationary object of mass 10 kilogram, but weight varies with respect to gravity, that means weight is equal to 980 Newton, 98 Newton and 9.8 Newton. If weight accelerates uniformly, then calculate final velocity after 10 seconds in each case. We have a given equation, formula, right? We can get easily final velocity. So in case 1, when mass is equal to 10 kilogram but gravity increases 10 times, weight becomes 980 Newton. Formula of weight is mass into gravity. Mass is 10 kilogram, gravity is 9.8, it becomes 98. But in that case, gravity increases 10 times, that means multiply 98 by 10, it becomes 980 Newton. So put the given value in that formula. Force is 10 Newton, time is 10 seconds, weight is 980 Newton, and initial velocity is 0 as object is stationary. So we get final velocity equals to 0.102 meter per second. In second case, when mass is equal to 10 kilogram but gravity equals to 9.8 meter per second square, weight becomes 98 Newton. That means mass into gravity 10 kilogram into 9.8 meter per second square, it becomes 98 Newton. So put the given value in that formula. So force is 10 Newton, time is 10 seconds, weight is equal to 98 Newton, and initial velocity equals to 0 as the object is stationary. So we get final velocity equals to 1.02 meter per second. In last and final case, when mass is equal to 10 kilogram but gravity decreases 10 times, weight becomes 9.8 Newton. That means formula of weight is mass into gravity. Mass is 10 kilogram, gravity is 9.8, it becomes 98. But in that case, gravity decreases 10 times. So divide 98 by 10, it becomes 9.8 Newton. So put the given value in that formula, right? Force is 10 Newton, time is 10 seconds, and weight is 9.8 Newton, initial velocity is 0. So we get final velocity equals to 10.2 meter per second. To conclude, we can affirm that final velocity increases as a result of decrease in weight, or you may say final velocity decreases as a result of increase in weight, which proves my point.
In order to make things clear, let's consider yet another situation.
If a truck of weight 4000 Newton is moving with a constant velocity of 4 meter per second, then what amount of net force is sufficient to stop that truck? Calculate it. Net force. Confused? Not able to calculate it? You know why? Because the scientific convention establishes to us is F is equal to ma. That doesn't capture the above scenario, as truck is moving with a constant velocity. It is not accelerating anyway. Hence, Newton's second law of motion fails here to calculate net force. So, what should be its solution? Here we go. In that case, formula becomes weight into change in velocity. That means force is equal to weight is 4000 Newton and final velocity is 0 meter per second and initial velocity is 4 meter per second, and we get force is equal to 16,000 kilogram meter square per second cube, or you may say 16,000 Nefaria. What is Nefaria? One Nefaria force is that force which produces change in velocity of 1 meter per second in a body of weight 1 Newton. If that is the formula of force, then what the heck is force is equal to weight into acceleration? Let me explain you. Force is equal to weight into velocity, or you may say weight into change in velocity, is a formula of net force, that means Newton's second law of motion, whereas force is equal to weight into acceleration refers to rate of change of force, that means inertia, right? It is a formula of inertia, not formula of force, and you may say formula of Newton's first law of motion. There is a big difference between force and inertia. Here we have two buckets and two water bottles. Each bottle contains 1 liter water, right? Now I am going to pour the water of both bottle into these two jars, right? Let's go. As we can see, bottle A is empty now, but bottle B is still pouring water. Bottle B also gets empty. Right? Let's move on to the slide. Let us assume that bottle A poured water in 1 minute and bottle B poured water in 2 minutes. So, bottle A poured 1 liter water in 1 minute. That means 1000 ml water in 16 seconds, and we get 16.66 ml per second. What is that? That is rate of water poured. That means bottle A poured 16.66 ml water per second, and bottle B poured 1 liter water in 2 minutes, right? That means 1000 ml water in 120 seconds, and we get 8.33 ml per second. That is rate of water poured of bottle B. That means bottle B poured 8.33 ml water per second. Let's calculate how much water bottle A poured and how much water bottle B poured. That means net water poured, and its formula is equal to rate of water poured multiplied by time taken. Let's calculate net water poured by bottle A, and it equal to rate of water poured of bottle A is 16.66 ml per second, right? And time taken is 16 seconds, and we get 1000 ml water, right? That means bottle A poured 1000 ml water, or you may say 1 liter water, and bottle B, net water poured by bottle B, is equal to rate of water poured of bottle B is 8.33 ml per second, and time taken is 120 seconds, and we get 1000 ml water. That means bottle B poured 1000 ml, or you may say 1 liter water. So bottle A and bottle B poured 1 liter water, but rate of water poured is different. So there is a big difference between rate of water poured and net water poured. Exactly the same difference is in between force and inertia. Let me explain you with an numerical. Let us assume a truck of weight 4000 Newton moving with a constant velocity 4 meter per second. In case 1, truck stops in 10 seconds, and in case 2, truck stops in 40 seconds. So find inertia and net force. In case 1, inertia equals to, what is the formula of inertia? Weight into acceleration. Weight is 4000 Newton and acceleration, final velocity is 0, initial velocity is 4 meter per second, and time for case 1 is 10 second, and we get inertia equals to 1600 Nefaria per second. What is Nefaria? 1 Nefaria force is that force which produces change in velocity of 1 meter per second in a body of weight 1 Newton. Move on to the numerical. What does that mean? That means truck applies 1600 Nefaria force per second. Right? Move on to case 2. Inertia is equal to, weight is 4000 Newton. Acceleration, final velocity is 0, initial velocity is 4 meter per second, and time in case 2 is 40 seconds. And we get inertia equals to 400 Nefaria per second. That means truck applies 4000 Nefaria force per second. It is inertia. Let's calculate net force. The formula of net force is rate of force applied multiplied by time taken. Net force of case 1 is, rate of force applied in case 1 is 1600 Nefaria per second, right? And time taken is 10 seconds, and we get net force is equal to 16,000 Nefaria. Let's calculate net force of case 2. Rate of force applied in case 2 is 4000 Nefaria per second, and time taken is 40 seconds, and we get net force equals to 16,000 Nefaria. That means in both cases truck applies 16,000 Nefaria force, but rate of force applied is different. So there is a big difference between inertia and net force. It is a formula of Newton's first law of motion, and it is a formula of Newton's second law of motion.
When an object moves with constant velocity, it needs continuous supply of constant force to maintain its velocity. But F is equal to ma tells no force acts on it, as acceleration in that case is 0.
So in that case, formula becomes F is equal to Wv under gravity and F is equal to mv in space for object that moves with constant velocity.
Now that I have established that force has two units, so there are two paths available for me to go with convention and ignoring all the uncomfort to be faced by me from the scientific community, or to undertake research and pursue for right thing. And I will prefer to go for the right thing, as it is very easy to explain for me because there is only one thing that brings that thing. Look carefully, it is evident by above scenario that a quantity may have two units if and only if it acts under different conditions. Let me present you another situation. When we apply force on a ball, we are not able to calculate it. As ball produces no acceleration, so Newton's second law of motion fails here. The thing is that practically we are applying force on a ball, but theoretically we are not able to calculate it in numeric. You know why? Because the established convention given to us is F is equal to ma, that bound us to calculate that type of forces. So what would be its solution? Let me present you. Suppose we have a weight machine, right? Suppose, assume this is a weight machine, right? I stand on it. When I stand on it, my body is not accelerating and not producing any velocity, and I get my weight in numeric, right? Exactly same. If we paste weight machine on a wall and apply force on it, then we can get force in numeric. So that weight machine can be further modified into force meter. Towards the end, I would like to see your valuable suggestion towards the issue, and your feedback should be duly acknowledged. Thank you and have a nice day.